It's Orkan. Welcome to my channel. Today we are going to solve combination sum 2 problem. It's very similar to the combination sum problem that we have solved earlier in this channel. So let's see that what is this problem is about. So the problem is that we have input array, and we need to find the and we are given a target. We need to find all combinations that in sum give us that target. So the first important requirement is that our combinations should be unique, and another one is that the clarification actually put here that the solution must not contain duplicate combinations. So for example, let's take example 2, easier to explain with this example. So for example, we have 2 5 2 1 2, and the target is equals to 5. So we may have, for example, 1 2 2, and so for example 2 2 1, and we may also have that this one 2 1 2, but that's actually, in this case, that would be qualified as a duplicate. So let's see how we are going to solve this problem. So let's work on the second example and see that how we are going to solve this problem. So we have the first thing that we need to do. We need to sort that input array. So this input array of 2 5 2 1 2, we sort it and it becomes 2 2 2 and 5. And also we have a target in this case, which is equals to 5. So the target equals to 5. So we can qualify this problem as a backtracking problem, and for the backtracking problem, as in the combination sum, it's actually, as I mentioned earlier, it's a very similar problem. So we need to define the base cases. Base case, for example, in this case would be that it either should equal to 5 or our combination sum, and in that case we add that combination to our result. And another one is that if our combination is more than 5, in that case we are also backtracking. Okay, let's actually see that how we are going to generate our tree. So for example, for this case we have 1. So another one is that so we are going over, so we can use every element only once. So we are going and generating 1 and 2. So we are basically building our tree. So next one is that the 1 2 and 2. So okay, is this combination is more than or equals to our base case? It's actually exactly equals to our base case. So what we do, we are backtracking from this branch. Okay, so the next one is that we are going to the so we used first 2. So we exhausted this branch, and we are backtracking, and now we are moving our pointer to the next 2. So that would be 2 2 and 2. Okay, so in this case, is it actually equals to our base case or more than our base case? It's exactly equals to our base case. So we can also qualify this as a valid combination and add that to our result. But obviously we have here duplication, 1 2 2 and 1 2 2. How we are going to solve this problem? So the way we are going to solve this problem, we are going to use the hash set. So basically we are going to use the hash set that when we are adding our combinations, that will only, so that the second one will be rejected because it's already duplicate. So we can go on and generate the tree. So but I guess the idea is clear. So basically from the 2 we are moving to 1 2 5. So is it equals or more? So actually it's more than our base case. So we are backtracking from this branch. The same here. So the next one is that we have exhausted for 1 to 2, and the next one is that we are moving to another 1, 2, and generating all possible combinations for that for this scenario, for the second 2. Okay, so that's our algorithm that we are gonna use today to solve the problem. So let's put this solution to code. Okay, first thing that we need to do is to create a backtracking method. So that method won't return anything. We can call it simply BT, like it stands for backtracking. So we are gonna pass our candidates. We are gonna pass our target here, and also we need a few other arguments, input arguments, input parameters. So the first one is that as we have agreed, we are gonna pass. We are gonna use a set to store our results, in order to not to add the duplicates. So that's going to be a set of lists of integers. Let's just call it set simply. And another thing is that we need somewhere store our temporary result that we are going to decide at the point when our combination is equals to target. We are going to decide should we add that to our set or we should not. So let's call it just a temp. And also for generating our possible scenarios, we need some index to go over our array. So let's that should be integer. Let's call it just the start. So in our next iteration, that will be a starting point. Okay, so the first thing that we need to do, we need to create our for loop and go over our array to generate all possible scenarios. We are going to start with the start, and I should be less than candidates length. Okay, and we are just going to increment our I. So first thing that we need to do, we need to add to our temp. Let's add our candidate at the time, candidates I. Okay, and after that we need to go further and create all other possible scenarios, all other possible combinations. So we need to call our backtracking method again recursively and pass their candidates our target. So what we are going to do here, instead of adding for example, instead of adding 1, 2, 2, that is equals to 5, we are going to subtract from our target. For example, we are going to subtract first 1, then we're going to subtract 2, and we are going to subtract 2 again. When our target is equals to 0, then in that case, we are going to consider that as a valid combination and add to our set. Or if it's less than 0, it means that our combination exceeds our target. We're just going to backtrack. So we're going to do that a bit in reverse order. That's just easier to code. So from our target, we are subtracting our candidates. And from our target, we're subtracting our candidates. We are just passing the same set, and we are passing temp, and we are incrementing. Since we are moving we cannot use the same element. We should move to the next element. We are incrementing our index. And so the next thing is from the temp, we need to remove. This is our temporary list that we are using. So we are adding there our combination at the time, but also while we are backtracking, we need to clean up our temp array list. So for that reason, we just remove the last element while we are backtracking, -1. So Another thing is that that's how we are generating all our possible scenarios. But as we have agreed in the explanation part, we have two base cases. The first base case is when the combination is more than target, we should backtrack. In our case, so it would be if the target is less than 0. So in our case, it's less than 0, as I said, because we are subtracting from the target. If let's say that, for example, we subtracted 1 to 5, 1 to 5 is more than target, so in that case we need to subtract, and for our scenario it will be a negative. So in case of negative, we are just subtracting. So in case of negative, I mean that we need to backtrack, so we are here backtracking. That's the first base case. Another one is that so if the target is equals to 0, then in that case, if the target is equals to 0, so then it means that so for example, 1 2 2, right? 5 minus 1 minus 2 minus 2 equals to 0. So that's our valid case, valid combination. So we are adding to our set. We are adding our temp, but we are not adding our temp. And we are returning. So here actually we need to add not the temp, but the copy of the temp. The reason is because if we are going to add the same temp, so all lists in our set, they will point to the same array list in the heap memory. So in order to avoid that, we need to take the copy of the list at the moment. So that's why we are making a copy of it. So we are making the copy of it and adding that copy to our set. Okay, so that's it. That's actually our backtracking method, how we are generating our all possible scenarios, and how we are backtracking if we hit our two base cases. So let's in our main method, let's sort first our candidates. And we have agreed in the explanation, but first thing that we need to do, we need to sort that array, and after that we need to create a result that we are going to pass to our backtracking method. So we need to add here list of integers, and let's call it just set. Okay, so and as we have agreed that should be hash set, because with that way we can only that way we can make sure that our combinations are unique. And so yeah, the next thing is we just need to call our backtracking method. So here we will pass the candidates. We are going to pass our target. We are going to pass our set. We are going to pass a temporary. For the temp, we are going to pass just the array list. Yeah, array list, and we're going to pass 0 because we are starting from the first element. That's it. And at the end, we need to return. We need to return actually array list, because the list of the list expected from us, not the set. So we are going to return our set. Okay. All right, so I think that's it. Let's see. So candidates, let me see, equals to start, int I, yes. Int I equals to start, I less than, okay. Okay, that's it. Actually, that's our code. So let's go one more time over it. So basically, one thing that we do is we are generating all possible combinations, and we have two base cases. So that's our backtracking method that recursively generates all possible scenarios. So in our main method, we are first sorting our array and calling our backtracking method, which is recursively generates the possible scenarios and add them to the result. And at the end, we are returning our array list because that's what I expected, not the set. That's it for today. Thank you for your time. If you have any question, please leave your comment below and I will respond to them. If you like my content, please hit the like button and subscribe my channel. Thank you for your time. See you next time. Bye.